Well, I completed building my heliochronometer. If you remember a few weeks ago I showed you a mock-up just to check on the build accurate methodology, and it's all done. It's made out of wood, burnt the numbers in it. And just to talk to you a little bit about how it works, the first thing you have to do is take this the whole sundial base and balance it. Make sure it's completely level. So I have a four-way level bubble, and I level that. I put leveling feet on the bottom of each of the corners so that I can make it perfectly level, because you want it to always be in the same orientation relative to the plane of the equator as it cuts through the earth. The second thing is you align the base of the unit so it's pointing north, which is at the bottom of the picture there. And it has to be aligned to the North Star, so again the angle is all correct relative to where the sun and the North Star is. The third step is you're going to adjust your latitude, actually co-latitude, on this arch, and there's a screw and a knob on the other side to loosen it and tighten it, and each of those black marks are co-latitude positions. I didn't put numbers on it, so I got a little but I know what the numbers are. And you just basically look up your latitude for your location, and the co-latitude is 90 degrees minus your current latitude. And so that adjusts the angle of the clock so that it's parallel with the equator. The next thing is you have to decide, you have to determine where are you in your time zone. So we're in the Eastern time zone, and it begins somewhere around New York and ends somewhere around Chicago. We're generally over there. So if you were actually at the beginning of the time zone, or right on what they call the time meridian for that zone, your line on the 12 o'clock would line directly up with this mark that's just underneath that center screw. But since we're in Perrysburg, Ohio, I have to adjust for longitude because time is a little different. Even though we say it's all the same time zone, it actually is different relative to the sun's position. So I would loosen the plate and then turn the plate, and if you look up your longitude for Perrysburg, it is 8.4 minutes west. And so each of these major lines are 5 degrees, and you turn that until you were at 8.4 degrees above the 12. Then when those four adjustments are set, the level, the north orientation, the co-latitude, and the longitude, you're now ready to read time anytime you want, summer or winter. So what you do then is you have to position the analemma, and the analemma is this device, which looks like a figure 8, and it's actually the way the sun would look. If you were to take a picture every day of the sun at noon, it would leave a shape like this. And it shows the relative path of the sun through the year, and you can see there's letters J for January, February, March, April, May, June, and so on. And because of where the declination is, that's how high the sun, or your latitude position, that's going to cause how high the sun is in the sky. When you're ready to take the time, you simply turn the analemma until this hole is pointed at the sun. And when it is pointed at the sun, the sun rays will come through here and leave a dot on the analemma board. You turn this dial until the sun dot is directly on the edge, any one of the edges of the analemma. And yesterday when I took this, I think it was October 29th, and the dot was right there near towards almost to November. And then once that's lined up, you come over and you look at the clock and you can read the time. And here we're looking at approximately 9:45. I got a little bit of light there. 9:45 on the clock. And the time actually was about 9:46, so it's pretty accurate. And then the only other adjustment that if you want to is you can actually make this daylight savings time or standard time, and you just simply turn this clock another hour one way or the other depending on what you're doing, whether you're jumping forward or falling back. At any rate, so that's a heliochronometer, and it's surprisingly accurate, and it was a lot of fun to make. Hope you enjoyed.